My name is Victor Monga. I'm serving as Vice Chairman of the board. For those of you who might be interested in learning more about me, please connect me over LinkedIn and or Twitter. Virtue Testing is a California incorporated organization. It's a 501c3 tax-exempt nonprofit. That means all donations paid to VT are tax deductible. VT was founded on simple concepts like curiosity and community. We service 3 centers of excellence. Education is to offer the community to speak, collaborate, hands-on learning, and grow. This helps our community members to amplify their skills to advance their professional careers. Charity is to offer fiscal sponsorships to groups and missions who do not have non-profit legal status. We enable them so they can start accepting tax-deductible donations without having to build and maintain non-profit legal status. Innovation is to work with our partners to crowd test new security platform integrations. We believe state-of-the-art technology can and should be accessible by anyone. We build partnerships with other organizations to collaborate and enhance experience for our members. VMware is offering hands-on labs to everyone. All you need is a valid email address to create an account. During this session, all opinions expressed are solely my own and do not express the views or opinions of my employer. Few things I would like to highlight. You don't need to install anything to explore VMware solutions through VMware Hands-on Labs. It is self-paced, so you manage your own schedule for hands-on learning. You can explore all of the features without having to be worried about if it is going to break anything. Even if you made a mistake, that's okay. You can start this lab or any other lab offered by VMware Hands-on Labs from the beginning. Let's talk about quickly the lab details we are referring in this session. It should take you about an hour and 30 minutes. There are a couple of modules in there such as vSphere 7 Overview, vSphere Lifecycle, Intrinsic Security, Application Acceleration, and the last, vSphere with Kubernetes. During this lab, you will explore solutions such as ESXi, vSphere, VCenter, and Kubernetes. A couple of things that you would need for the login steps. They're pretty straightforward, such as if you go to the URL provided in the show notes and on the screen, if you already have an account, you can use that email and password combination to log in. Or you can click on register to create a new account. Once again, you can use any valid email address. Doesn't have to be your corporate email address, doesn't have to be your employer's email address. Once you're logged in, you can start your hands-on login journey. Once you have identified your selected hands-on lab, in your case, we are exploring HOL 2111-01-SDC. Please make sure you run the test to ensure you can have a great lab experience. If any of these tests fail, please rectify that issue to the best of your ability before you start your lab. And the last step, click on the Start Lab and voila, you're in. So let's lab. Once you're in the lab, make sure lab status is ready. If it is not, please wait for it to show up as ready. If it takes more than 15 to 20 minutes, you can exit out of it and re-enroll to restart the lab. With that, let's jump into our lab environment. Once I'm logged into Hands-on Labs successfully, usually I choose to split screen for lab manual, so I can use an entire screen for lab area while reading through lab manual on my second monitor. You can use a tablet for second screen as well by simply scanning this QR code. So I'll show you how you can do that. Click on more options here, then click on split screen. You can either click on this URL, which will open lab manual on your second monitor, or you can scan this QR code from your tablet, or you can email that QR code to any device that you can open this lab manual. Now I have my lab over here and the lab manual on my second monitor. There are two parts of the lab I always explore once I'm in. First is the operating system. So first thing you want to do is read this file readme, which will give you more information about the lab, the credentials that you would need to log in. Second part of the lab is that you are familiar with the desktop icons. You can go ahead and click on them. Also, once you're familiarized with the operating system and the icons, that's where we'll start logging in the solutions and start looking at it. So we'll log into vCenter since we manage all ESXi hosts, virtual machines, distributed storage, and distributed networking using vCenter only. So let's log in. First, let's review host and cluster view. Once we are logged in, we'll go to menu. We'll click on host and clusters. This view gives us information about data center, which is right here. When you create the vCenter, you'll create a data center. Then you'll create a cluster, and then you'll add virtual machines under these hosts. So the hierarchy, the way it works is, first you have a vCenter, you'll create a data center right here. You'll create a cluster under that data center. You'll add your host under that cluster, and your virtual machines are part of these hosts. If you have more than 2 vCenters sharing the same single sign-on domain, you can view them together, which simplifies the admin tasks. In our case, we have VCSA-01A and we have VCSA-01B. So these are 2 different vCenters that we can see from single sign-on login because they're sharing single sign-on domain. The next view we're going to explore is going to be VMs and templates. This is where you can organize your virtual machines in folders. The third view is storage. This is where we can see local or distributed storage connected to the host which are being managed by your logged in vCenter. And the last, my personal favorite view is networking. We'll be offering separate sessions for this view and options, but for now, please click on it, familiarize yourself, please go through these options. Now, as per the lab guide, our first task is to check the VM compatibility. So we're gonna click on Core A. We're gonna click on Updates. We're gonna check the status. So if you click on it, you'll see the status that it was just checked right now. And you'll see an upgrade is available. You can see the details. The current version is version 17. That's what's running on the host, which is ESXi. And this virtual machine, it is running version 10. So you can see it as an upgrade is available. In our case, why don't we go ahead and try to upgrade this virtual machine from version 10 to version 17. So we'll click on upgrade to match the host. You can view these recent tasks here. And it has been matched, as you can see. Please make sure to read through all the module materials to learn about additional information offered by VMware Hands-on Labs. Our next task will explore VMware Lifecycle Manager. So click on Menu, click on Lifecycle Manager. Please follow along the lab manuals as well. Then we'll click on Updates. You can filter these IDs. So as you can see, I filtered 700 number, and I can see right here that in the IDs I have filtered the 700 number. You can also choose different vCenters. So I will choose VCSA-01B. And I can filter by name as well. So if I know that I have a name, Broadcom, I can see these names here. Now the next task we will explore is going to be vSphere Lifecycle Manager Baselines. So we will click on Imported ISOs, click on Import ISO. Once again, please continue to follow along the lab manuals. We will select this ISO, open. It is going to import it. All right, we have an ISO imported. It took us about 60 to 80 seconds, so be patient about it. Let's click on this ISO, new baseline. Here you can enter any name. I will put it actually testing. You could put any description. HOL session. Click next. You will select the ISO that we just imported. Click next. Please review this summary. All right, we can see that. So let's review. In baseline, we can see the one we just created. Okay. Now let's use it. So let's go to host and clusters. Then let's select a host, ESXi-01A. Click on updates. Once again, please continue to follow along with the lab manual. Then we will come here, click on attach baseline or baseline group. So here I'm trying to attach it, but I can't see the one I have created. And the reason for that I have just realized is because I had created that under VCenter B. So if we go to baselines, so as you can see, you have to be making sure that you're creating it in the right vCenter. So let's do it again for vCenter A. Same process. We'll import the ISO. All right, it's adding to the repo. Now let's go to baseline, new. Let's add a name. This time I will specify that it's for vCenter 1. Description could be anything.
vCenter Server 7 introduces Update Planner. Update Planner is part of vSphere Lifecycle Manager and is used to facilitate vCenter Server updates. Update Planner handles updates, patches, and upgrades all within the same interface, further simplifying vCenter Server lifecycle operations. Update Planner automates the following steps of an update. Discover the current vSphere version and details. verify compatibility against the target vCenter server version, verify interoperability of the target version with other products, as well as recommend, create, and test vCenter server update plans.
In vSphere 7, there is a brand new feature called Sever Profiles, which allows you to export existing vCenter server configurations from one node and import them to another vCenter node. So let's explore. Here we are showing that in API, you can actually try it out. Here's how you can download these JSON files. So if you just click on it, it's going to download that file for you. So once you have that file, you can export configuration from one vCenter server and take that, review it, change it, this JSON file before importing, or you can directly import it to another vCenter node. Now from here in the lab guide, you'll learn and review the new feature in vSphere 7.0 about platform services controller being converted into embedded appliance automatically. You can review vCenter service nodes in system configuration. So let's look at it. Menu, administration, deployment, system configuration. There we go. I can see my both vCenter appliances. I can click on view topology. I can zoom in. Let's switch it back to table. You can also log in directly to your vSphere server appliance directly from here. So if I click on login, it's going to open that up for me for credentials. Next, you'll watch a video about upgrade migration improvements in vCenter Server 7.
Upgrade and migration have been simplified in vCenter Server 7. Platform Services Controller convergence now happens automatically during a vCenter server upgrade or migration. If the SSO domain includes any external PSCs, the upgrade will converge those PSCs to an embedded vCenter server during the upgrade process. Alerts for this new process are shown to make the administrator aware. Any external PSCs that have not been converged during an upgrade or migration must still be decommissioned via the cmssoUtil command. Bringing these two workflows together as one further simplifies the steps to upgrade your vCenter server. This also keeps the vSphere SSO domain in a supported topology. When completed, vCenter Server 7 shows off its redesigned summary page. Quickly identify your vCenter server's version, build number, last update, as well as last file-based backup of the vCenter server. Clicking on the backup date quickly brings you to the vCenter server management interface page to review backups.
All right, our next topic is vCenter server configuration backups. There are two ways to log into vSphere Appliance Management Interface, also known as VAMI. One is directly log into using vCenter Appliance DNS and a port number 5480, or from vCenter server itself that I've shown in the previous session. So let's look at it. Administration, deployment. Let's click on login. Or you can directly log in right here. Both methods are fine and they're going to get you exactly to the same spot. So let's click on login. Let's click on backup. Please follow the lab manual on step 95 where we're going to set up backup and the schedule. So let's click on backup now. In the lab manual there's a location. We will be using that to configure as backup location. So it is going to be FTP 192.168.110.11. Please clear this username and enter administrator core.local, and the password is VM capital where 1 bang. We're going to leave the encryption password blank. We're going to disable the DB health check, which takes a long time. If you prefer to do that, please go ahead. Keep that in mind. It is going to take a long time to run the backup then. We're going to select stats, events, and tasks. Inventory and configuration is selected by default. You can add a description. It could be today's date, it could be some tag, it could be if you're running this as one-off before any upgrade, you can add a description as well. With that, let's click on Start. Alright, it will take about 7 to 10 minutes to complete this one. If you want to take a coffee break at this time, please go ahead. Once it is complete, you'll see that it's completed. I'll show you the time it has taken, 5 minutes 13 seconds. From here, let's go ahead and configure schedule so that we don't have to run this one off every time. We'll go ahead and put the backup location, which is exactly the same that we just used. So it'll be FTP 192.168.110.11. Please go ahead and remove this username, and we will add the username given in our lab guide. Local password is capital VM lower where 1 bang. We're going to leave the encrypt backup password blank for now. DB health check again disable. Retain all backups. Keep these all checked. And we'll go ahead and create it. Now let's go ahead and verify it. We can see it is set as daily 11:59 p.m. We have a location, we can see the data, and we can see number of backups to retain configuration. In the lab manual, you'll review content library and VM template management improvements as next. So please go ahead and read through it and explore those options. Now the next topic is certificate management. vCenter server has done some interesting things to help make certificate management easier. There are now REST APIs for handling vCenter server certificates. So let's go ahead and explore. Click on Menu, Administration, Certificate, Certificate Management. You can see we have these machine SSL certificates and trusted root certificates here. Next, we're going to explore APIs. So click on Menu, Administration. This time we'll click on Menu, Developer Center. And then from there, we'll click on API Explorer. Select our vCenter. Select our vCenter as endpoint and select API as vCenter. And here we go. We can see the APIs. VMCA is just enough certificate authority to manage the vSphere cluster's cryptographic needs. It should not be confused with a general purpose certificate authority, also known as CA, like those that are often found as part of enterprise PKI infrastructure. You cannot ask the VMCA for a certificate for your company's website. You will also explore vSphere certificate management modes in lab manual. Our next task is how would you import and replace a certificate? So let's go ahead, click on Menu, Administration, Certificates and Certificate Management, click on Actions, Import and Replace Certificate. From here you can choose your option which needs to be, and you can go ahead move further. In this lab, we're going to cancel this from here. Now next you're going to hear about vSphere Identity Federation.
Hi, I'm Bob Plankers. I'm a technical marketing architect with VMware Corporation, and I'd like to talk briefly about the vSphere Identity Federation. Something you hear a lot in the information security space right now is that identity is the new perimeter. And that's especially true for organizations that are gearing up to support remote workers and work being done on mobile devices. It's very important that people be able to authenticate themselves and that organizations can trust that that is the right user, that you are the authentic user for a document, an email account, some sort of resource. Alongside patching, good identity management. Identity management is one of the biggest ways that an organization can stay secure. And to that end, organizations are looking to consolidate their authentication into dedicated identity providers. They want to have flexible options for multi-factor authentication and other authentication mechanisms. They also want to reduce risk. These federated solutions mean that applications don't have to handle credentials directly any longer, and that's a boon to compliance and risk efforts. Finally, it provides a consistent user experience, which is both good for support, but also enables users to be able to rapidly detect fraud, phishing, and other attempts to steal passwords, bad actors trying to steal their credentials. This is really where Identity Federation shines. vSphere Identity Federation uses the industry standard protocol OIDC, it's based on OAuth 2, to connect to these systems and to participate in the corporate and enterprise identity federation solution. So what does this mean in practice? Let's draw a little bit. Well, this is a traditional vCenter server, a VCSA, connecting to Active Directory using integrated Windows authentication, or LDAP, LDAP-S, hopefully. And a user comes along and vCenter processes that user login through its own web interface. Well, how does this change when we talk about identity federation? Well, first, for Active Directory, there's ADFS, the Active Directory Federation Services. And instead of us talking directly to Active Directory, we're not going to do this anymore. A user approaches vCenter. If they don't have an active login, an active credential, they are redirected out to ADFS. ADFS will pop open the corporate login box, and they can enter their information. Providing they entered it correctly, they are redirected back into vCenter with a token. That's how these systems work, with a token. And the user can continue to do their work just like nothing has happened. The whole process is very easy. Many internet services use the same mechanism. Many corporate authentication systems use these same types of mechanisms, so they're familiar. It provides a great user experience, and it's got the ability to consume these centralized enterprise authentication mechanisms very easily. So it's really a win-win for everyone. Hopefully this answers some questions about an identity federation. Thank you. Have a good day.
In the lab manual, you will learn about vSphere Trust Authority. In the lab, we do not have TPM information, but this is where you will find it if you have that in your lab or production environment. You'll come here, click on Monitor, you'll click on Security, and this is where you can find that information. As I said, in this lab, we do not have that information, so it is not shown in this lab. Next topic is vSphere Trust Authority. VTA establishes its own management cluster, which serves as a hardware root of trust. You'll watch a short video about this.
Hi, I'm Bob Plankers. I'm a technical marketing architect with VMware Corporation, and I'd like to introduce the vSphere Trust Authority, or VTA. VTA is a foundational piece of technology that allows us to take workloads that require a higher level of trust, ones that have encryption enabled, VM encryption, virtual TPMs and the like, and tie that to a hardware root of trust in order to be able to establish trust all the way up from the hardware to the workload itself. What is a hardware root of trust? When I say that, I mean the trusted platform module inside of a server. A TPM is just a chip inside a server that helps measure, process, and report on the boot process for an operating system like ESXi. In turn, we can use that information to do something that's called attestation. Attestation is just simply ensuring that the configuration and the boot process ran as we expected, and it booted a known good operating system in a known good configuration. Let me show you how we establish that root of trust. First, we need to create a TCB, a Trusted Computing Base, or the VTA cluster itself. This can be your existing management cluster, if that's part of your design, and then you've got separate workload clusters. But for the most secure implementations, we recommend this be a separate cluster and implement the least privilege principle. Small group of admins, adminning just that VTA cluster. This allows us to use this cluster then to attest, to verify the workload clusters, and in turn mark them if they pass attestation, their configurations are known good, they're running the copy of ESXi that we trust, we can mark them as trusted. This has got a few practical implications to it. Like I said, you can build a separate cluster. You don't need to use the same hardware as the workload clusters or your management cluster. You can use your management cluster. You can use smaller pieces of hardware if you'd like. You don't need separate vCenter server instances. You don't need separate VTA clusters for different vCenter server instances. You can reuse the VTA cluster for multiple vCenter instances and vSphere instances. You also need TPM 2.0 support in all of your hardware. Most servers you buy now will have that in it, or it's an installable option. Most servers that have been manufactured in the last decade can be retrofitted with it. Just check with your server manufacturer. There's some other practical implications. Traditionally, with VM encryption, things like that, the KMS systems and the vCenter server instances talk to each other, and then vCenter handles distribution of the key material to the ESXi hosts. In this model, vCenter doesn't talk to the KMS. The VTA cluster talks to the KMS, and then cryptographic materials flow out from there, and so on and so on. This may also have implications for KMS licensing, so you might want to check on that. Last, this also means that this cryptographic material will not be pushed to a server that isn't trusted, that doesn't pass attestation, isn't marked as good. So if we've got an untrusted server here, perhaps a configuration change happened, maybe somebody disabled secure boot. That would definitely make a server more untrustworthy, less trustworthy. This cryptographic material would not flow to that. VTA would not mark it as trusted. And then a workload that is trusted could not start or move to this host. That's exactly what we want, right? We don't want our trusted workloads on untrusted hardware. Like I said, VTA is a very foundational technology, and we're proud of it for a number of reasons. Not only does it improve security, but it does it in a way that's light on operational staff as well. Y'all have enough to do with your lives, so making it easy to be more secure is a definite goal of ours. Hopefully this answers some questions about VTA. Thank you for watching.
Next, you will learn about secure enclaves. You'll watch a short video about that.
Hi there, my name is Bob Plankers. I'm a technical marketing architect with the VMware Corporation. Let's talk a little bit about vSGX, or Secure Enclaves. vSGX is virtualized SGX. SGX is the Intel Software Guard extensions, and that's a feature of various Intel CPUs that allow us to create secure enclaves or secure repositories for our secrets that we keep in applications and such. What secrets might we have? Well, cryptographic keys are the big one that comes to my mind, but it could be HR records, it could be the locations of my secret bases, whatever, With traditional hardware and traditional virtualization up until this point, What we've had is an application running inside of a guest OS, running inside of a hypervisor on a piece of hardware. Makes a lot of sense, right? That application has a secret. Well, and that secret is really held in memory. You know, everything on a piece of hardware is held in memory. But to get to that secret, to get to that memory, you have to traverse a couple of different layers. You know, the application talks to the guest OS. The guest OS can see into the secret, right? You know, I guess into the secret. The ESXi can see into the secret. And as far as a risk sort of thing, even though we trust ESXi completely, it's the most secure hypervisor around, and our guest OSs properly patched are doing pretty well as well. It's just extra components we don't necessarily want to have access. So if we use SGX, vSGX on a VM, we turn that on, and then these boundaries become hard. All of a sudden, these layers can't see in anymore. And that prevents the guest OS. Something happens to the guest OS and an intruder is in there. It can't see, they are not going to be able to see that. ESXi, again, if something should happen, somebody can't see inside of that. It's just between the application and the hardware itself. There's a few caveats here. A wise man once said that there isn't such a thing as a free lunch. Well, that's true. You need vSphere 7 or above. You need hardware, VM hardware version 17 and above as well. This also impacts the application design as far as vMotion is concerned. Because ESXi is the thing that vMotions VMs around, and it can't see into the secret, it can't move it somewhere else. So in order to do maintenance, to do normal lifecycle operations, you're going to have to take that into account. It's not an insurmountable problem, just something to consider. Last, this is a very CPU feature-dependent feature. The hardware itself needs to support it, and there's only a certain number and type of CPUs that allow this and that have this functionality. Definitely check the VMware, the vSphere compatibility guide, or what we often call the HCL, the hardware compatibility guide. Also, Intel has got a website, ark.intel.com, which will tell you all of the features available in the CPUs you have or might be looking to acquire. For more information, you can check out our blogs, blogs.vmware.com/vSphere. You can also go to vSpherecentral.vmware.com for lots of information about security and vSphere features in general. Thank you for watching. Have a good day.
If you're curious about persistent memory, this video will give you some information about PMEM.
After viewing this video, you will have a better understanding of and can get started using PMEM. Persistent memory, or PMEM, is also known as non-volatile memory, or NVM. PMEM is persistent. That means it's capable of maintaining data even after a power outage. You can take advantage of this by using it with applications that are sensitive to downtime and require high performance. You can configure your VMs to use PMEM on a standalone host or in a cluster. PMEM can be used in multiple ways as byte addressable NVDIMM or vPMEM disk. PMEM has lower latency than today's flash storage. Although it is not as fast as traditional RAM, it can be used as both. You can use PMEM with virtual machines in two different ways. You can use virtual persistent memory, or vPMEM, so that the memory is exposed to a guest OS as one or more virtual NVDIMMs. You can also use virtual persistent memory disk, or vPMEM disk, where the memory is accessed by the guest OS as a virtual SCSI device. When you use vPMEM disk, the virtual disk is stored in a PMEM data store. vCenter Server and Distributed Resource Scheduler automate initial placement of PMEM data stores, and this automation saves time and provides the ideal placement for the data stores, which is especially useful when using PMEM with legacy systems. Once a VM is initially powered on, PMEM is reserved for it regardless of whether it is powered on or off, and this reservation ensures that the PMEM will be available for the VM when it is powered on again. The PMEM stays reserved until the VM is migrated or removed. Since PMEM is a local data store, if you want to move a VM, you must use storage vMotion. Keep in mind that a VM with PMEM can only be migrated to an ESXi host with an existing PMEM resource. On the other hand, A VM with vPMEM disk can be migrated to an ESXi host even if there is no PMEM resource.
In our next video, you will learn about assignable hardware, which greatly improves how that you can utilize hardware accelerators.
Hi, welcome to this video. I'm Neel Shah and I work for the Cloud Platform Business Unit at VMware. In this video, I would like to discuss a new capability that we have introduced with vSphere 7. We are talking about assignable hardware. Assignable hardware basically means that we have recreated the portability for virtual machines that are assigned to a PCIe device, a hardware accelerator, for instance. Now, we used to have direct path I/O. And this is basically a virtual machine and a guest running inside the virtual machine. And the virtual machine and the guest are basically directly connected to a PCIe device. So the hardware address of this specific PCIe device is hard-coded. The hardware address is hard-coded in the VMX file of that specific virtual machine. Now, while this brings bare metal performance because you have a one-to-one relationship, it also came with a lot of constraints. So we don't have any option for vSphere HA to kick in, and we also do not have the DRS logic in place. With assignable hardware in vSphere 7, we are introducing dynamic direct path I/O. What this is basically a layer in between, which is all about the capability of a specific PCIe device. So now, rather than having that hardware address set up directly in the virtual machine, we are now doing that in the capability mapping layer, if you will. So basically, we'll expose to the virtual machine that we need a GPU. And we need a GPU model of that, for instance, an NVIDIA V100 Tesla. Now, assignable hardware together with DRS will basically look up if there is a host in the cluster that has this specific card and if it's available as well. So DRS will do the initial placement for such a virtual machine. Let me emphasize that it's not yet ready for vMotion because we still have not the capability to move a virtual machine that is directly connected to a PCIe device and live migrated to another host, but it is about initial placement first. Now, in the process, because we now have initial placement with DRS, we also benefit We also benefit from vSphere HA. So before, whenever a host with a direct path I/O setup virtual machine, whenever that host was failing, the virtual machine basically could not be restored or re-registered and restarted at a surviving ESXi host. Now with dynamic direct path I/O, we bring back that capability for PCIe devices that are directly connected to a virtual machine using dynamic direct path I/O. So that is great news. But this is only about direct path I/O. We also have the support for NVIDIA vGPU. Now, basically the same is going on. We have a virtual machine with a guest, and that guest, we have some other prerequisites as well for using NVIDIA vGPU. But basically, we are now having a PCIe device, which is obviously a vGPU capable GPU device, which is connected, and the same capability mapping will now look for a specific profile. an NVIDIA vGPU profile. Now again, in vSphere 7, we will take care that the initial placement is done for a vGPU. So whenever you have a specific profile set up for this specific virtual machine, DRS will now look at, hey, that profile, is it available at all the hosts? And where can I basically register this virtual machine and power it on? This is great for bringing portability back. And like I said, with Dynamic Direct Path I/O or with NVIDIA vGPU, we have a specific capability and maybe a specific model, but we can also use a custom label. So maybe this is about a GPU. Maybe we have a specific network interface card, a NIC as well, that is configured for latency sensitive workloads, for example, directly linked to a virtual machine. We can do the same with Direct Path I/O, and we can maybe introduce a custom label as well that is specific for specific network requirements, right? So a lot of possibilities, a lot of freedom of choice here. But in the end, the key takeaway is that we now reintroduce portability for virtual machines that are using Direct Path I/O with Dynamic Direct Path I/O, and we have that same capability for NVIDIA vGPU-enabled virtual machines.
Now, the next topic is DRS, Distributed Resource Scheduling. This is the most used and recommended feature for enterprise-level software-defined data centers. DRS was introduced back in 2006. It has been involved along with data centers and workloads. The enhanced DRS logic is now workload-centric rather than cluster-centric. Now let's go ahead and look at this in our lab. So we'll go ahead and click on our cluster region A, 01, comp 01. We'll click on configure. Then we'll click on vSphere DRS and we will click on edit. We will enable vSphere DRS. Automation level, we will select fully automated and we'll click on OK. Keep in mind, it is lab environment, so you won't see the best score you would expect in your production environment. Although let's talk about new DRS features. It computes a VM DRS score on each host and moves the VM to the host that provides the highest VM DRS score. Now, VM DRS score is not a health score for the virtual machine. Once again, VM DRS score is not a health score for the virtual machine. It improves the balancing by focusing on the metric that you care the most about, the virtual machine happiness. The DRS now runs every minute. If VM DRS score is between 80 to 100%, that indicates that there is mild to no resource contention. In previous DRS, it used to run for 5 to 6 minutes. In this new vSphere 7.0, DRS now runs every minute. It does not necessarily mean that a virtual machine in the 80 to 100% bucket is doing way better than virtual machine in the lower buckets. That is because there are many metrics that influence the VM DRS score. Not only performance metrics are used, but capacity metrics are also incorporated in the algorithm. Now let's look at it. How does it look like? This is what our DRS score looks like. So we have a cluster score and then we have a VM DRS score, and you can read more about it. You can also click on view all VMs. This is going to give us DRS score by virtual machine as well. Let's hear from Niels Haggard, Technical Marketing Architect at VMware.
Hi, welcome to this video. I'm Neel Shah, and I work for VMware in a Cloud Platform Business Unit. In this video, I want to discuss with you what is new with DRS in vSphere 7. Let's first take a quick look at what we did with DRS 1.0. And even though there's no real versioning in DRS, it's just DRS, let's stick with that name for the sake of this video. 1.0, or the DRS prior to vSphere 7, right? what we did whenever we had a VM in a cluster, so these are all ESXi hosts, right? And we used a cluster-wide deviation model, meaning that DRS wanted the hosts to be sort of equally utilized. So whenever we saw that we have, for instance, high memory pressure on this specific ESXi host, we could move the virtual machine that is responsible for that specific memory load, we could move that to a different host. In the end, what we wanted to do is sort of create that baseline that everything is equally utilized. Now, there's a lot of metrics that come into play with DRS, even with the older DRS that we used. But this is basically the model that we have been using since the inception of DRS. So DRS 1.0, or the older DRS, was about cluster-centric. And important to know is that DRS by default runs each and every 5 minutes. Okay? Now let's look what we changed up with vSphere 7 and already in VMC since the M9 release. So now if we look at what we have done with DRS in vSphere 7, or whenever you use VMC, VMware Cloud on AWS, we stepped away from the cluster-centric focus. So if we think about this as the DRS 2.0, and remember, it's not a version, it's just a way of explaining that this is the new version, the new way of doing things. It's just called DRS whenever you look it up in the UI, for example. Now, we are no longer cluster-centric, we are now workload-centric. Meaning that whenever we have a virtual machine running on an ESXi host, we calculate something that is called the VM DRS score. This is a new construct basically. And we use this score to verify if a virtual machine is scoring enough, if it's happy enough, right? And we have several metrics to calculate the VM DRS score. The first ones are basically performance driven. Think about CPU readiness time. Think about VM memory swap, about CPU cache behavior. All those metrics have a great impact on the VM DRS score. But it's not only about the performance as well. It's about the capacity of the ESXi host themselves. Meaning that if we look in at all the ESXi hosts in the cluster, we look at the headroom that a specific ESXi host has. So for instance, this ESXi host here has a lot of headroom, right? And that is also something that we incorporate into the VM DRS score. So can the application itself burst enough on the host that it is running on right now? So all these things basically, and there's a lot more metrics in the background as well, basically come up with that VM DRS score. Now we calculate that score for this specific virtual machine on each and every host in the cluster, and we will do so each and every minute. Remember, with the older version of DRS, we used 5 minutes. So it's far more granular approach, far more fine-grained. So whenever we have a virtual machine DRS score and we come up with, hey, this virtual machine is probably better off here, we'll also calculate the cost. The cost of moving that virtual machine with vMotion, if DRS is set to fully automated, the cost of the migration from this host to this specific host. In the end, we don't care so much about the specific utilization of all the ESXi hosts themselves. It is really about the workload. And that is the biggest difference that we have compared to versions prior to vSphere 7.
Our next topic is very much related to DRS, which is vMotion. vMotion can be in three ways: compute resource only, storage resource only, or compute and storage together. DRS defines what needs to be balanced, and it uses vMotion to actually execute or carry it out. When a vMotion is initiated, we copy the memory of a VM in multiple iterations. During the memory copy, the guest and the application running in the VM keep changing memory pages as vMotion is a live migration. Before we continue this conversation, let's actually show you all how vMotion works in our lab. So I've selected this virtual machine which is powered off. It is placed on ESX02. So if I would like to vMotion it to ESX-01A, I will right click on it. I will click on migrate. These are the three different types that I was referring to. It can be compute resource only. What that entails is CPU and RAM. It could be storage only. So what that means is it will remain on the same host, which is ESXi. It will migrate the storage part of it. We also refer to it storage vMotion. Or we can do both. We can do compute and storage at the same time. Now, for example, we are going to consider compute resource only. So let's go ahead and migrate it to ESXi01. As you can see, it has been migrated to 01A via vMotion. In the lab manual, you'll read about enhanced vMotion features in vSphere 7. You'll read about loose page trace install. You'll read about page table granularity, switchover process improvements. Last topic of this session is vSphere with Kubernetes.
I'm Michael West, Technical Product Manager with VMware. vSphere with Kubernetes exposes a new set of services that developers can consume through the Kubernetes API. The VMware Tanzu Kubernetes Grid service for vSphere allows developers to lifecycle manage Kubernetes clusters on demand. The network service enables integrated load balancing, ingress, and network policy for developers' Kubernetes clusters. The storage service integrates vSphere cloud-native storage into Kubernetes to provide stateful application support with persistent volumes backed by vSphere volumes. The vSphere pod service takes advantage of the other services to deliver pods natively on ESXi. The primary place that customers will run pods is in the upstream-aligned, fully conformant clusters deployed through the Tanzu Kubernetes Grid service. The pod service complements the TKG service for specific use cases where the application components need the security and performance isolation of a VM in a pod form factor. And finally, vSphere with Kubernetes has a native registry service that can be used to deploy container images as Kubernetes pods. Application-centric management means that policy has been attached to namespaces that contain developers' applications. Operations teams now have a holistic view of an application by managing the namespace that contains all of the application objects. Okay, let's see how this works. This is a simple declarative YAML specification for a Kubernetes cluster. The Kubernetes cluster kind is defined through a set of custom resources that are part of the VMware Tanzu Kubernetes Grid service for vSphere. Applying that YAML specification creates your Tanzu Kubernetes cluster. The kubectl get command shows we created a 2-worker node cluster. The network service works with the Tanzu Kubernetes Grid service for vSphere to provision load balancer-based access to the Tanzu Kubernetes cluster. The storage service provisions the cluster nodes based on the storage classes defined in the specification. Developers can use the registry service to stage container images in the built-in Harbor registry for use by the vSphere pod service to deploy pods directly on ESXi. With VMware Cloud Foundation services, infrastructure is managed as code. and developers can take advantage of the entire Kubernetes ecosystem, including source code repositories like Git. As developers leverage VMware Cloud Foundation services, the operations teams have a real-time view of the activity in vCenter. Tanzu Kubernetes clusters and pods running directly on ESXi are visible in the inventory view. As the developer deploys their application, the vSphere pod service provisions the pods directly on ESXi, and the network service creates the ingress to the application through a native load balancer. In this example, we create a persistent volume claim, which causes a vSphere volume to be created and bound to the claim. We then deploy a pod that mounts that volume. Finally, we create a deployment of web server pods to provide our application's user interface. Access to the UI is through a load balancer provided by our network service. Keep in mind that TKG clusters are the primary way that developers will deploy their applications. And TKG clusters also make use of the network and storage services. The pod service gives the developer the option to deploy pods on TKG clusters or, for specific use cases, directly on ESXi. They are complementary services. Each of the Kubernetes objects has its own inventory item. Pods are running as first-level objects directly on ESXi. They have their own summary and detail screens. Tanzu Kubernetes clusters have an inventory object with details on the cluster and individual virtual machine items for the VMs that make up the cluster nodes. All of these are layered under the namespace they were created in. Namespaces provide an abstraction that holds both Kubernetes and vCenter policy. Through integration with vSphere single sign-on, operations teams assign users or groups access to a namespace. Storage policies are also assigned. This assignment causes storage classes to be created in both the supervisor cluster and in your Tanzu Kubernetes clusters for use by the storage service. CPU, memory, and storage limits can be assigned. Namespaces are backed by vSphere resource pools that enforce the CPU and memory limits through DRS. Storage limits are pushed into the Kubernetes clusters and are enforced through resource quotas. The platform promotes collaboration between developers and operations teams. vCenter provides deep visibility into all of the objects created by the developers. Compute objects like pods, deployments, and Kubernetes clusters, storage objects like persistent volume claims, network objects like load balancers, and even Kubernetes events are surfaced to the operations team. All of this in the context of the namespace to align infrastructure objects into application-centric management.
A Tanzu Kubernetes Grid TKG cluster is Kubernetes K8's cluster that runs inside virtual machines on the supervisor layer and not on vSphere pods. It is enabled via Tanzu Kubernetes Grid service for vSphere.
VMware Tanzu Kubernetes Grid service for vSphere provides infrastructure to enable developer self-service cluster lifecycle management. Clusters deployed through the TKG service are the primary way that customers will deploy Kubernetes application components on vSphere. Developers submit a straightforward declarative YAML specification to the supervisor cluster Kubernetes API for the cluster configuration they want. In this case, the Tanzu cluster resource holds the configuration for a 3-node cluster with fully reserved memory resources, running Kubernetes version 1.16 and Calico as the overlay networking within the cluster. The Tanzu Kubernetes Grid service controllers generate the corresponding cluster API and virtual machine resources for this cluster. The VM operator watches virtual machine custom resources and reconciles the desired state versus active state by creating the appropriate virtual machines. kubeadm configuration is passed into the virtual machines to bootstrap the control plane and worker nodes into a Tanzu Kubernetes cluster. Our cluster specification will define a single node control plane with 2 small worker nodes. The nodes will be placed on data stores that comply with our storage policies. Calico will be used for the overlay networking. We submit the specification using the kubectl CLI. Notice that this creates the Tanzu cluster object that holds the configuration for our cluster. The operations team can see the Kubernetes cluster as a new inventory object in the Hosts and Clusters vCenter view. This object includes details of the virtual machines that make up your Tanzu Kubernetes cluster. Tanzu Kubernetes clusters are integrated with vSphere single sign-on. The kubectl login command builds the context into the kubeconfig file for use in authenticating to the API of the new cluster. After logging in, we set the context to point to our Tanzu Kubernetes cluster. Users with the edit role on the supervisor namespace have the admin role in clusters created in that namespace. We validate that by seeing all of the namespaces within the Tanzu Kubernetes cluster. Now, let's deploy an application on our new cluster by applying a different YAML specification. Notice that we have created a deployment and a load balancer type service. An NSX load balancer VIP was automatically allocated for this service. We validate that the application is running and that we have ingress to the web page by using the load balancer VIP. Now we can scale out our cluster. First, we modify the specification file so that the desired state for our cluster is 3 worker nodes. We then set our context back to our supervisor cluster namespace and apply the specification again. Our Tanzu cluster resource is updated and the virtual machine operator creates a new VM for the worker node. Finally, the vCenter Kubernetes cluster object is updated with the new VM that was created and configured as the new worker node.